Okay, you're welcome to this channel. We are going to solve some simple problems involving algebraic identities. Many persons know this identity, but they don't know how to prove the identity. For example, we have a square minus b square. We have square of a difference. You have square of a sum. You have difference of two cubes, sum of two cubes, cube of a difference, and cube of a sum. These are some of the identities that are common in algebra, but many persons don't know how to prove this identity. So we are going to start with the first one, which is common, the difference of two squares. So how do we prove this kind of identity? So I want to show you two methods of proving these identities. One is algebraic technique. The second one is geometric system. So I'm going to draw a square. It's not according to scale. And I'll draw another small square here. Yeah. So I have two squares. So the whole of this is A. So if the whole of this is, so here will be my B. The whole of this place will be my B. Here will be my B. So I have A and A here. So the area of the big square is A times A, which is A square. Please follow me closely. The area of the small square is B times B, which is B squared. So the area of this empty space from this area to this region is the difference of the squares, and that is going to be A square minus B square. So if I subtract the area of the smaller square from the bigger square, I'm going to have this region, this shaded region, That becomes the difference of the squares. That becomes the area of that region. So what I'm going to do now is I'm going to show you something, a demarcation somewhere that will make this proof elegant. So along this region, I will divide this. So if you look at this now, this axis now will become A minus B, and this other region will become A minus B. Now I have two rectangles. I have this dotted one, which I will call P, and I will have this one with this slash, which I will call Q. So the area of this rectangle is the A, the length times the breadth. So I call P, the area of P is A bracket A minus B. And this rectangle. Now this other small rectangle here that is attached to this square will be, this is still B, will be B times A minus B. So my Q will be B bracket A minus B. Now you can see that the area, their total area will be P plus Q. So total area will be P plus Q, and that will be A bracket A minus B added to B bracket A minus B. So you can see if you are doing factorization, once a factor is common, you write it down, A minus B, and then you pick the other one, A and plus B. So you can see that the difference of the square A minus B square, which is this entire two regions, will now be A plus B and A minus B. So this is one of the systems, the geometric system for proving difference of two squares. Now, what if you want to use the algebraic technique? How do you solve this? Okay, so you have your A square minus B square. Now, A and B are common in this square, so we take their inner product, and that will be A multiplied by B, and that is AB. Now, I can add two factors of AB to this without changing anything. So I will have my plus AB and my minus AB. I can insert it inside this. I'm going to have A square minus AB plus AB minus B square. This doesn't change anything, but I can group them to form something meaningful. So I'll have A square minus AB plus AB minus B square. So inside of this, I will have A bracket A minus B, and plus B is common. I will have my B bracket A minus B. So A minus B and A minus B are common. So I will write down A minus B, and I have my A plus B. So you can see that these two now has given rise to A square minus B square. So if you use the algebraic technique, you get the same answer. If you use the geometric system, you get the same answer. So please subscribe to our channel and follow these accounts or page. I will also post more of these identities and more problems in mathematics. Thank you so much.